In this video, we're going to go over a very cool word problem, similar to one we did in a previous video with a graph, but now we're going to show how to solve it without a graph and using the square root method of solving quadratic equations. Let's go. Big word problem, not so bad though. It's one of those word problems in name only that if we just read a little bit, it's telling us a lot of backstory. A giraffe drops a fish off a cliff to her narwhal friend 120 feet below. Interesting. The equation h of t equals negative 16t squared plus 120 represents the height of the fish, h, above the narwhal t seconds after it is dropped. So all of this basically says that this equation gives you the height that this fish is at any time as it does its descent off of this cliff. So you plug in t equals 1, you'll get the height after 1 second has gone by of where the fish is off of the water where the narwhal is. By the way, a narwhal is a very interesting looking fish with one heck of a pointy, well, it's actually a tooth, but it almost looks like a unicorn fish. Anyway, how much time has elapsed when the fish is 50 feet above the narwhal? How much time passes when the fish reaches the narwhal? All right, so we've got two different questions here. Let's go with the first one and let's tease out this equation because we're basically being asked to use that equation. H of t is equal to negative 16t squared plus 120. All right, let's rock and roll. So, if we want to know how much time has elapsed when the height of the fish is 50 feet above the narwhal, I'm really just telling you in this word problem, h is 50. That's all of what I'm telling you there, right? It's how high we are. So that's 50 is h, and we want to know what is the time when the height is 50. So now knowing that translation, all we have to do is solve this equation and we'll have how much time has elapsed, the value of t. How we also know that we're solving for t and not h is that it says how much time, meaning we don't know what t is and we need to find it, given the height. Okay, so we're just going to solve it like a normal equation now. So I subtract 120 from both sides. And if you have trouble solving these kinds of equations, go back to my prior video and how to solve them, right? Because this is now old hat at this point. That's going to be negative 70, 50 minus 120, leaves you with negative 70 equals negative 16 times t squared. Divide both sides by negative 16. Beautiful, beautiful. I did that already with a calculator. Negative 70 divided by negative 16 is 4.375 is equal to t squared. Now in this case, because time is not negative, I am not going to take plus or minus the square root. You're not going to have a negative time. So that is why, for the real world problem that this is, I'm just taking a positive square root. All right, so when I take the square root of 4.375, I get approximately 2.09 seconds. So that's the amount of time that will have elapsed when the fish is 50 feet from the narwhal. Okay, or a height of 50 feet off the water. Now we're going to go to the second question. How much time passes when the fish reaches the narwhal? So, well, if the fish has reached the narwhal, presuming the narwhal's in the water, right, then it's at a height of 0. That's the assumption we're making. So how long until the fish hits the water, which is a height of 0? So that means we're now saying when h is 0, what is the time going to be? So 0 equals negative 16t squared plus 120. Ah, it's a beautiful thing. So again, the height is 0. We want the time. Now all that's left, now that we've done that translation, is to solve. So what you're going to notice is the solution process is the same. The only difference is the height is at 0 feet now because we're hitting the water. And if you imagine it, it's now how long until we get there? Okay, anyway, great illustration, right? Clearly, I'm not giving you videos on how to be a better artist. That's for sure. So 0 minus 120 is negative 120. We had that the 120 is canceled out on the right-hand side right here. Now we're going to divide both sides by negative 16. Again, the same exact steps we did in the previous part. So negative 120 divided by negative 16 is 7 1/2, or 7.5. And like I stated here, because it's a real world problem where time is not negative, I'm only going to take the positive square root. So here we go, positive square root of both sides. And that leaves me with t is approximately 2.74 seconds. This second part of the problem is one of the most I wouldn't say important, but one of the more popular word problems that's going to come up. It's the idea of when does something hit the ground, and that happens when the height of that something is 0. Awesome stuff, peeps. Seeing that long word problems don't necessarily mean a ton of thinking, they just mean focusing in on the key parts, making a simple translation, and the rest is algebra. Sweet.